Hello and welcome to this demonstration video of the PureData patch which I've created for my honours project. This is an algorithmic composer. I won't be going into the specific techniques that it uses in detail in this video, but generally it's framed within a generative grammar and uses some other techniques as well, such as Markov chains. The aim of the project was to investigate how effectively algorithmic composition could be used to create chiptune music for use in games. So the sound that we're going for here is something like what you might remember from old 8-bit games like Mario, Legend of Zelda or Metroid. It's aimed at small or solo game development teams who might not have dedicated audio staff, so the idea was to allow people to create music for their game even if they didn't have any musical experience themselves. The way this is achieved is through the parameters here. So these allow you to describe a scene that you might come across in an 8-bit game. And these parameters are mapped to variables such as key signature, tempo, and note duration, so that hopefully the end result is something that matches the scene we've described. So let's give it a listen and select some parameters. So we'll go for above ground, let's do some platforming, maybe mid-game, and yeah, let's keep with bold. So if I hit compose, we get some information here about the type of composition that we've generated, and we can give it a listen. Okay, well that was kind of a frantic one, I suppose. That's the thing, is that these songs are as new to me as they are to you, so it's what's come out of the testing as well, that sometimes the compositions are kind of unpredictable, and especially like as you heard in that one with the note duration, like quite often it'll be very sort of fast and rapid, kind of erratic sounding notes like that. But I mean, hopefully to you it sounded as though the two instruments that we're playing were fairly in tune together, and yeah, maybe somewhat evocative of the scene that we described. Just to see if we can get a variation, I'm going to try a different setup. So let's go for an underground one. Let's fight a boss at the late game, and yeah, let's have a scary boss. Well, that one was a bit more on point. Maybe it was sounding maybe slightly sinister and scary. We could hear there that the note duration was a bit more in control of itself, I think. Yeah, we'd like to try another one, I suppose. Let's have a reflective mid-game collecting expedition. Let's keep it underground and see what that comes up with. Yeah, I don't know how reflective that one was sounding. I think perhaps like with the D minor key signature there, it was sounding just a bit more sort of, we're still getting a bit more of the underground spookiness coming through. But yeah, with it being a collecting activity there, that was affecting the note length, tending towards a longer note length. So we weren't getting quite the sort of frantic kind of sounds that we were getting in the earlier ones. So yeah, I think that's probably kind of shown the main findings from this project, I guess, that the compositions it comes up with are still fairly unpredictable, even given the parameters. And as I'm going on to talk about in the write-up, that the different ways that we might address this with to do with how the parameters are, the variables that are mapped to these parameters, how they're actually selected. But yeah, that's showing it working, I suppose, and yeah, hopefully giving you an idea of the sorts of things that it produces. I wanted as well just to give you a brief sort of overview of the app itself, or the patch rather. So the interface here, we've got our parameters that we can select from. To compose a new one, that's our button there, and the play and stop button. For read, that was really just for debugging. So what that does is it will force the instruments that are playing to reread the text files that the actual note data is stored in. So it allows me to effectively like to load a previous composition. So if we go in here to control, this is the kind of guts of the patch, I suppose. So we've got all of our input parameters coming in here and then getting sent to this composer object. So the composer object is, this is an extension that I've written in C. So this is where all of the generative grammar and Markov chain stuff is happening. Yeah, which, as I say, we weren't going to really go into in this video. So the composer outputs basically the data that forms the composition, and it's putting out here 5 different streams of information. So I'd originally written this to accommodate up to 4 instruments, and then we've got an extra track here for the actual for some of the overall song data. So this is things like the tempo and some other things that I can't remember just at the minute. So we've got the instrument data coming out here, and this is recorded to a text file. So that allows me to save previous compositions if I wanted to, and also it was really important during development to debug and find out what it was actually producing. The text files are then read back into these arrays, which is what we use to which is what the instruments use to actually play the song back to us. So we've got our metronome here, which is the sort of main step of the this is basically our sequencer, I suppose, that's giving us an idea of time. And then here we've got the different instruments. As I say, we've just got the 2 instruments in this implementation. So the actual instrument subpatch is here. That's the one that's used for the bass. So what's getting fed into this is basically a sort of a Boolean value to say whether the note is on or not. So when we hit a note from the metronome, we know whether or not this instrument is going to be playing on this note. And then we get the note velocity, the pitch as a MIDI note, and also the duration. So if we look into our instrument here, so we've got this instrument set up to emulate a triangle wave, which is like based off the NES sound card. I suppose it used a triangle wave for its bass sounds. So we've got our triangle wave here, and then over at this side we've got the ADSR envelope. So this is where we can control the duration of the note by affecting the sustain component of that. And then for other instrument. So we've got this one set up as a square wave. Although the NES used a pulse wave for its sort of two melody channels that it had, I couldn't get a pulse wave that sounded good at the range of frequencies that this needed to play without having to introduce an extra step to control that. So the square wave is used here just because it's a bit more reliable across that range of frequencies. Yeah, and we've got the same kind of layout here. We've got the actual instrument and then the envelope on this side where we can control the duration. And yeah, this stuff down here was just some debug stuff, and also to allow me to record the compositions. That hasn't been fed through to the sort of the front interface at this point, because it wasn't something I was intending for users to be able to do during the testing. Yeah. So I think that's all there is to say on it at the moment. Thanks very much for watching. Goodbye.